Hello, my name is Ashish. This is my first assignment on tall buildings. I have made my model as per the tutorials. Let us open the model. Click on File menu, click Open. Select the file which we want to open. Click Open again. The model created has been opened. Let us illustrate the steps involved in the creation of the model. To create a new model, go to File menu, click on New Model. Change the setting as shown. Change the display units to metric SI. Change the steel section database to Indian. Select the steel design code as IS 800 2007. Select the concrete design code as IS 456 2000. Click on OK. A new window will appear. In this window, we have to input the grid dimensions. In our model, the number of grid lines in X and Y direction required are 4. The spacing of the grids in X and Y direction is 6 meter. Now let us input the story dimensions. The total number of stories of our building are 23. The height of every story is same, that is 3 meter. So we have to enter the value 3 meters to the typical story height and the bottom story height. Since the plans of the stories is varying in every floor, so we will select the custom story data option. Click on Edit Story. In the new window appeared, we will group the stories which have same plan and properties. To do so, as we know that stories 1 to 8 have same plan, so make any of the stories the master story. Here we will make story 8 as the master story. Now we have to make all the other stories similar to story 8. Now the story 1 to story 8 are into a single category. Similarly, story 9 to story 14 have same properties. So we have to make any of the stories as master story. We will select story 14 and make the rest of the stories similar to story 14. Now story 15 to story 19. Make story 19 as the master story and rest of the stories similar to story 19. Now story 20 to story 23 have same properties. Here story 23 is already selected as master story and the rest of the stories are similar to them by default. Click on OK. Click on OK again to create the grid. Remember to select the grid only option. The grid has been created. We are back to our building model again. We have drawn the grid lines. Now, to draw the elements of the buildings, that are the beam, column, slabs, we have to first define the material properties and the section properties of the elements. So let us define the material properties first. Go to define, select the material properties. Click on add new material. Select the region as India. Select the material type as required. For concrete, select concrete. For rebars, select rebar. We will select concrete. Select the standard as Indian. Select the grade as M40. Click on OK. Click on OK again. Similarly, we have defined HYSD 500 rebars and mile 250 rebars. Click on OK. After defining the material properties, let us define the section properties. Go to define, select section properties, click on frame sections to define the beams and columns. Here we have already defined the section of the beams, which are B500 by 300, B550 by 350, B600 by 400, and similarly we have defined the column properties. To add new properties, click on add. Select the desired shape for the section. Here we will select rectangular concrete section. Change the property name of the section. Change the material to M40. Change the depth and the width as required, that are 300 mm by 300 mm. Click on Modify or Show Rebar to change the properties of the reinforcement. Here we are designing the beam, so click on Only Beam option. Change the rebar material for the longitudinal bars as HYSD 500 and for the confinement bars as mile 250. Change the cover depth for the top bars to 25 mm and for the bottom bars as 25 mm. Click on OK. Click on OK again. Here we can see that our section is being defined. Similarly, define the other beam sections which are required and the column sections. Here we have already defined the required beam and column sections, so we will delete this new created property. Click on OK to finish. Now we will define the slab section. Go to define, section properties, select slab sections. We have already defined the slab section as slab 150. The property name is slab 150, the material selected is M40 and the slab thickness is 150. Click on OK. Click on OK again. Now we have defined all the material properties and the section properties for the elements. Let us draw the elements of the building one by one. We will demonstrate the drawing of the elements for the stories 9 to story 14. Let us go to story 9. Click on Plan button. Select story 9. Click on OK. We can also toggle between the stories using the arrow keys in the bar. The plan view for the story 9 has been opened. Let us draw the columns for the section first. Go to Draw Beam Column Brace Objects. Select Quick Draw Column option. The Quick Draw option is used when the elements are intersecting with the grid. Change the column properties in the tab opened below. Select the area covering the grid intersections where we have to locate the columns. We have located our columns as required. Now let us draw beams. Go to Draw Beam Column Brace Objects. Select Quick Draw Beams or Columns. Change the beam property in the tab below. Select the area where we have to locate the beams. We have successfully located our beams. Let us draw the slabs. Go to Draw. Select Draw Floor or Wall Objects. Click on Quick Draw Floor or Wall. Select the slabs by clicking one by one. Press Escape to exit the Draw menu. To draw cladding walls, go to Draw, Auto Draw Cladding. Select Use Floors option. Click on OK. The cladding walls are being drawn. In this way, we have to complete our whole building model. To define the supports, let us go to the base of the building. Click on Plan. Click on Base. Click OK. The base plan view has been opened. Select all the intersection joints. Go to Assign, Joints, Restraints. Click on Fix Support. Click OK. The fixed support has been applied. Now we have to assign loads on the created model. First, let us assign the dead and the live loads. To assign the dead load, select the All Story option from the list. To assign the dead load, select all the slabs. Now go to Assign, Shell Loads and Uniform. Keep the load pattern name as dead. Enter the uniform load value as per requirement. In this case, it is 2 kN per meter square. Click on Apply. Click on OK. Similar, now we will apply wind load to our model. For wind load design, we have to define the load pattern. Go to define load patterns. Enter the load name as wind, load type as wind. Select the IS code for the wind design, that is Indian Standard 875 1987. Click on Add New Load. We have already created the load pattern. Go to Modify Lateral Load to enter the data for the wind design. To enter the data for the wind design, we have to refer to the Indian Standard Code 875. Enter the wind coefficient data referring to the Indian Standard. Here we have already defined the wind coefficients. Click on OK. Click on OK again. To apply the wind load, click on Assign, Shell Loads, Wind Pressure Coefficient. Change the wind load pattern name to wind. For the wind pressure coefficient value, we have to refer to the Indian Standard Code 875. For the windward face, select windward option, and for the side faces, select leeward or side option. Click on Apply. Click on OK. We have successfully applied all the loading conditions. Now we will run analysis on the structure. To run analysis, go to Analyze, Run Analysis option. We have now done with our analysis part. So let's design the structure elements. To design the structure elements, go to Design, Concrete Frame Design, click on View or Revise Preferences. Check the design code selected is IS 456 2000. Click on OK. Now go to Design again, Concrete Frame Section Design. Click on Start Design or Check. The design of the structural components have been completed. We can see the reinforcement details in the 3D view diagram. To see the values of the reinforcement, we can zoom in or out. We can also print the reports in the report section and the project report. With this, we have successfully completed the analysis, modeling and designing of the tall building structure. I would like to thank Skyfi Labs for providing me an opportunity to learn.